The purpose of this video is to show you an example of how to change the equation of an ellipse from general form to standard form, and also how to graph an ellipse. We saw in class that an ellipse can be defined as the locus of points where the sum of the distances from the two foci is constant. You drew in the major axis, which goes through the two foci, and it's the longer axis of symmetry. You also drew in the minor axis, which is the shorter axis of symmetry. This animation just shows an example of what it was like when you traced the ellipse in class today. And so notice that the sum of the two distances from the foci, which served as the string that you tied, remains constant as the length of that string did not change. There are two standard equations for the ellipse. One is for an ellipse that is horizontal. This is the one that looked like the one you drew today on your 5x8 index card. This has the format of the equation of x minus h squared over a squared plus y minus k squared over b squared equals 1. Notice that this is different. When we saw the equation of a circle, this number that was the constant on the right-hand side of the equation was rarely 1. For an ellipse, that number will always be 1. In addition, you have how to find the foci. We're adding the value of c to h, subtracting the value of c from h. Notice that that affects the x-coordinate. And that's because, again, this is a horizontal ellipse, so we're going to be moving away from the center of the ellipse in a horizontal direction. HK still represents the center. You'll be able to find C by using a form of the Pythagorean theorem, C squared equals A squared minus B squared. By completing your construction exploration, you should be able to understand why that is the case. Likewise, you have your formula for the vertical ellipse. What I'd like for you to notice is the difference between where A and B are located. A squared will always be located underneath the variable on which the major axis is located. So for example here, A squared is under the x variable. That means that the major axis is horizontal. In this equation at the bottom, A squared is found as the denominator underneath the y variable, which says that the major axis is vertical. This will of course change how you find your foci, as this time from the center we're moving in a vertical direction as opposed to a horizontal direction. So now we're going to be adding or subtracting c to or from k. Just as we've done before with circles and parabolas, in order to write the equation of the ellipse in standard form, we're going to complete the square. That's not any different for both x terms and y terms, making sure we move that constant term to the other side of the equation. Once we are done, we're going to divide all of the terms by that constant value that we moved to the other side. Let's take a look at how this looks in an example. We're given general form, x squared plus 9y squared minus 4x plus 54y plus 49 equals 0. First, let's group those x terms and y terms together. Those were some great suggestions given in class to help make this more visually appealing. You'll also see that we have subtracted 49 from both sides, putting that constant term on the right-hand side. Now it's time to complete the square. Remember to take the middle term, have it divided by 2, and then square it. We do that for the middle term of the x trinomial as well as the middle term of the y trinomial. I want you to notice that with this y trinomial, we did have to factor 9 out so that the coefficient of the squared term would be 1. Now we're completing the square. For the x trinomial, 4 is the number that would complete the square. For the y trinomial, 9 is the number that would complete the square. But notice for the y trinomial, we have that 9 that served as the GCF that we factored out earlier. So we're really not adding 9 to both sides here. We're really adding 9 times 9, which is what you see on the right hand side here. We also added 4 to account for the 4 that we added when we completed the square for the x squared trinomial. Now we're going to simplify, write those trinomials as perfect squares of binomials. Notice that we still have this 9 in front. It hasn't gone anywhere yet. We've just simplified the trinomials into binomials. Then we'll divide both sides of this equation, all terms, by this constant. Remember, that has to be a 1. The only way you're going to get it to be a 1 is to divide all the terms by that constant. Dividing also helps us get it into the format of an ellipse. Next, we're going to simplify. And this is our final equation. X minus 2 squared over 36 plus y plus 3 squared over 4 equals 1. Notice that 36 is larger. A squared is always the larger denominator, which means A is 6, B squared is 4, which tells us that B is 2, and we'll use those as we graph. Now, in order to graph the ellipse, we're going to put the equation in standard form as we just did. Once it's in standard form, we'll be able to easily recognize the center as the ordered pair h comma k. We're going to graph the foci, looking at the equation to make sure we understand whether the ellipse is oriented horizontally or vertically. We're going to use a, the square root of the larger denominator, to show us how far along the major axis we should go from the center in order to graph the vertices. We're going to use b, the square root of the smaller of the two denominators, to let us know how many units to move away from the center in order to graph the co-vertices, and those will be along the minor axis. We'll then connect those vertices, and we would have a beautiful ellipse. Okay, let's take the example that we just had. Notice that 36 is larger than 4. 36 is found as the denominator of the x variable. Therefore, we know that this ellipse is horizontal, which means the major axis is in the horizontal direction. We can find the center using the equation h comma k, 2 comma negative 3. We've graphed the center here. We must find the foci. C squared is a squared minus b squared. So 36 minus 4 is 32. The square root of that is the square root of 32. If you take that square root, you'll get 5 point something, and so you'll estimate about 5 units and a little bit of change away on either side from the center in the direction of horizontal. We'll find our foci. Next, we want to graph our vertices. Take the square root of the larger denominator. That number is 6. Again, because this ellipse is oriented horizontally, we want to move 6 units in the horizontal direction from center. The vertices here are listed as E1 and E2. Next, you want to try to draw a smooth curve, as smooth as you can. I'm not going to grade you on your artistic ability to create that ellipse. Now, one thing you don't see on here is the co-vertices, that have been graphed. Notice the value of b squared is 4. So if I take the square root of that, that's 2, which means from center I would need to go 2 units in the vertical direction. So if I went up 1, 2 from center, that gets me that point. We'll label those in class tomorrow. If I go back to center and go down 1, 2 units, then I also get another point for the co-vertex. So this wraps up the video example of how to work with the equation of an ellipse, as well as how to graph an ellipse. We will work more tomorrow in class. Remember to watch this video as many times as you need to in order to make sense of it, and be prepared to ask questions tomorrow. I'll see you then.